Hello, welcome to Z Talk. This session, I will continue on where I left about Terraform Basics. If you haven't reviewed my last session and wanted to come with me to learn Terraform together from the beginning, I recommend you to go over my last video first to set up the environment on AWS. Today's lab will be an extension of what I have done in my last session. I attached the link to my last session above for your information. Okay, in last session, we were able to spin up multiple VMs via Terraform on AWS. However, getting VM up and running is just the beginning. We will need to continue on installing different softwares on the VM to set up whatever develop environment we need. So what do we need to do to include software provisioning into the process of automation is what I mainly like to share in this session. Basically, there are two ways of provisioning softwares. One is to build custom AMIs, which bundle your software and files in base image. There is no doubt that it is the best practice for your production environments. There are software like Packers that help you bundle your customization to the base image. I will have a session about it later. The other way is to install your stuff at runtime. Just note, this way is not recommended for a production environment. The purpose of demoing this way is to walk you through how do we build the blocks for installing the software to get you familiarized with Terraform Basics. Before doing that, let's talk about a couple of concepts. What are data sources in Terraform? Data sources basically allow data to be fetched or computed for use elsewhere in Terraform configuration. Terraform provides data sources for major cloud providers. For example, AWS provides a lot of structured data which can be accessed via AWS APIs. Terraform exposes those data using data sources like AMIs, availability zones, or etc. Terraform keeps output of all resources and its attributes. Outputs can be queried and retained. Output values are like the return values of a Terraform module and have several use cases. Like a child module can use outputs to expose a subset of its resource attributes to a parent module, or a root module can use outputs to print certain values in the CLI outputs after running Terraform apply. Okay, let's jump to the demo real quick. I'm gonna provision Nginx on the VM that we brought up with Terraform on AWS. Please remember thumb up and subscribe my video. Thank you. Let's jump to the demo. Okay, let's review what I've configured during my previous session for spinning up VM first. I created 3 files. Provider.tf defined my AWS account information like access key, secret key, etc. And remember, for security reason, I had to variabilize the values and store the real value in another file called variables.tf. Inside of these file, I also introduced a map type variable called AMIS, where I set up some default images that will be used based on region. And the main configuration was create instance.tf, where I define the name of the instance, the number of instances, and in which region they're going to be created. I used a lookup function to decide which image should be used based on the 2 variables that I defined in the variables.tf, AMIS, and AWS region here. So let's jump back to variables.tf. For this case, the default value for AWS region was US West 1, right? So the lookup function will look up the map variable AMIS to identify the US West 1 here and decide, okay, this image will be used for this region. Okay, finish up reviewing of previous code. Let's continue on to make it more robust. The first thing I can improve is the images. yes, I defined the default images in the map variable here. However, for getting those images ID, I had to log on AWS portal, create a new VM, and copy paste the MI ID here. And I had to Google like Ubuntu MI Finder to figure out what images are available on which region. So either way, this process is kind of cumbersome. Just imagine, what if I can pull all available images info from our script automatically? That case, data source comes to the picture. Remember, data source allows data to be fetched in the Terraform configuration. Okay, let's start create our first data source to fetch our AWS availability zones and store them to a variable called available. And then in the resource block, I created another parameter availability zone, and I'm gonna get access to the JSON data that was fetched and stored to available variable. Generally, there are 4 availability zones per region, but the actual number depends on the region. But we know it's gonna be a list. So this is how we get access to JSON data. So data and the label will be AWS availability zones, and the variable available is where all those data being fetched to. And I'm gonna fetch the name. So names, I will randomly pick 0 index, and I will change the other index to see the difference. All right. Before we jump to the terminal, let's go back to the variables. So the default AWS regions I chose was US East 1. So let's see. Go to the terminal and issue Terraform plan for the dry run, and let's see if it works. Okay, let's scroll up a little bit to find availability zone here. So you can see it's US East 1A. So let's change the index to another value like 3, and let's see the difference. Run that again. Scroll up. Okay, now this time it's switched to availability zone D, 1D, right? So let's give another value to see how many zones for this region. Let's pick a big number, 10. Let's see what we got. Here we got an error message because you see here, it's a list of string with 6 elements. So there are only 6 elements, and I type in 10, of course they're gonna return an error message. But basically it is, so it verifies what we configure here. Next, I create another data source to fetch MI data so that I don't have to use lookup function in the resource block anymore. I will replace lookup function to data.aws AMI at variable Ubuntu, and I'm gonna fetch the ID of the Ubuntu MI. For these data block, to better understand the configuration, as you see there are some weird parameters like owners and values. Let me jump back to the AWS portal. So when we are creating a new VM, the first step is to pick AMI images. So let's create a filter to show Linux-based AMI only, and we can see there are many options out there. You can see the virtualization type, root device type are same across the boards. The only difference is those images were provided by different provider. Some of them are Amazon, some of them are Red Hat. So there's the shortcut to find the right images for you. Let's jump to the AWS documentation and find a quick start AMI. By the way, I'm gonna share this URL to the description of my video so you can copy and paste and take a look. Here it lists out the command to locate the versions of quick start AMIs that are available in the region. Let's take a look. For example, Ubuntu. Here, that's where, remember those weird parameters in the config file? That's where it comes from. So you can see the owners, filters, and let's copy these commands and run it to see what it does. Copy that and go to the terminal and you paste that command, and you can see there is a AMI ID returned. That's exactly what we needed, right? So let's jump back to the Visual Studio Code and go to the variables, the Terraform. Now I can take these AMI variable out. Okay, so let's go back to the terminal and run Terraform plan again to see what we got. And here you can see it's this AMI ID was pulled out at runtime from these data source. All right, and just note the version might be different per region. So let's go to the variables, the Terraform, and change to another region like US East 1. And let's see if there are any difference. Before I run the Terraform plan again, just remember these image for a US East 2 was 68A, and let's see if the version is different. And let's scroll up. Yeah, it was different. See, for these region, the latest version was EB9. Here, just remember in the configuration you need to put in the most recent. Otherwise, it's not gonna return one value. It's return a list of versions available for that region, right? So we always use we always only need one images, so we pick most recent to true, so we're gonna use whatever latest version of that of Ubuntu image in that region. Now, since I'm gonna provision Nginx software at runtime, I prepared a shell script here. To do so, it will sleep until the VM is up and running, and then install Nginx via apt-get package manager and start Nginx as a service. Okay, next step, I'm gonna need this shell script to be uploaded to the EC2 instance that was created, and have Terraform get access to the VM via SSH to execute these shell scripts. For SSH instance on AWS, I'll have to have key pairs ready for authentication. So I jump to my terminal and generate a key pair by issuing SSH keygen, and I will store the key to a file called my key. So hit enter. Just hit enter empty for no passphrase, and hit enter again. Okay, so now you can see there are two files created. One is stores the public key, and the other stores the private key. I had the key pairs in place. Following the logic, let's update the configuration in create instance.tf file. Firstly, I added a resource block for the keys that I just generated in my terminal. By the way, I'm gonna switch between Terraform documentation and the code to explain what each of new functions or blocks that I use in my configuration does. The Terraform official documentation is gonna be my Bible for the configuration. Let's talk about this resource block first for the key pair. You can see I give the name of the key same as what I defined in my terminal, my key, and public key. So you can see I used a file function here. So let's switch to the documentation to see what this function does. File reads the contents of a file at a given path and returns them as a string. Okay. Here in the argument of this function, I defined a variable. So basically, I'm gonna store the location of my public key in the variables.tf file here. You can see here I define a variable called path to public key, and I make the default as my key.pub because I stored my public and private key in these here in the same location of my configuration. So I only have to use the relative paths. But if you, for your case, if you store your keys somewhere else, you can include the absolute path here. And once I define this variable in the variables.tf, I can call these variable from the create instance, the main config file, to get the location of the file, the location of the public key, right? So next, I'm gonna add a couple of provisioners inside of the main resource block to perform the logic that I explained earlier. Let's search for Terraform documentation to see what does provisioner do. All right, go back to the documentation, and provisioners can be used to model specific actions on the local machine or on the remote machine in order to prepare servers or other infrastructure objects for service, right? So there are different kinds of provisioners. So for my case, I added two provisioners. One is file, the other is remote exec. Let's see what each of the provisioner does. Firstly, file provisioner. The file provisioner is used to copy files or directories from the machine executing Terraform to the newly created resource. That's exactly what I needed, right? So I need to copy basically the script, the shell script I created right here to the EC2 instance that was created on the AWS, so that I can execute it. That's the plan, right? So that's why I added this file provisioner, and I for the source will be the location where I stored these shell scripts, which have the same folder of my config, right? The destination here is gonna be the EC2 instance where the this file will be uploaded to. So you can see it will be uploaded to temp directory. The next provisioner is for executing these shell scripts. Let's take a look at the documentation. The remote exec provisioner invokes a script on a remote resource after it is created, right? So I added these provisioner, and basically what it does is it change the permission of these Nginx shell script to executable, and then execute these this shell script on the remote EC2 instance. Regarding provisioner connection settings, based on the documentation here, because the provisioners require access to the remote resource via SSH, it is expected to have a connection block with details about how to connect, which was exactly what I did here in the connection block. Inside of this block, the first parameter host, you can see I used a function called coalesce. So let's jump back to the documentation to see what these functions do. Here, coalesce takes any number of arguments and returns the first one that isn't null. So basically what it does is just to return whatever IPs that comes available first. So it can use that IP to set up the connection. And you can also see in the arguments of this function, it used a self.attribute like public IP. So just take a note here. So based on the documentation, these self.attribute syntax is only allowed and valid within provisioners. Just remember that, right? And next parameter is type. So type equals SSH. And for users, these gonna be the user ID to get access to the VM that created on AWS. So you can see I create a variable on the other file. So I need to jump to the variables.tf. So here, same thing. I define the here private key, just like exactly what I did for public key. I define another variable to store private key and another variable to define the name of the instance. So it's gonna be Ubuntu, and this is my private key. It's saved in the same location of the of my configurations. So I just provide the relative path, right? So go back here. So here I call those variables to grab the information, right? So now we're good. Let's take a dry run on terminal to see if there are any syntax error. Here, just issue Terraform plan. Okay, cool. Everything looks good. There is another preparation on AWS side that we need to take care of. Basically, we have to modify the security group on AWS portal because we're gonna create SSH connections from my local machine to the EC2 instance on AWS. The IP address of my local machine has to be added in the whitelist of EC2 instance. Otherwise, the connection will fail. Actually, why don't we just issue a Terraform apply command to see what issue we're gonna get before I update the security rule. Let me jump to my terminal and issue Terraform apply. Here, just type in yes to approve. Basically, because my IP has not been added into the whitelist, the connection attempts will be repeating, and it will be blocked, and we will see basically this message showing creating instance repeating until this procedure get timeout. It's gonna take a little bit of time before we see timeout. So while we're waiting, let's get back to our code and continue talk about security rule. we're gonna need another rule for the EC2 instance in place for enabling HTTPS for us to getting access Nginx from anywhere else. So that's our goal for this session, right? So what we can do on our script is to automate this rule definition process by creating another data source to fetch all IP ranges in that specific region where we're gonna deploy the EC2 instance, and we can define ingress rule to open the Nessus reports for all CIDR blocks in that specific region. Back to the Visual Studio Code. So I created another config file called security rule.tf, where I firstly created the data source to fetch all IP CIDR blocks in US West 1 region and for service EC2. And then down below in the resource block, I open up 443, which is for HTTPS in the resource group for all CIDR blocks once for all, basically in West 1 region, so that the port 443 for any EC2 instance in that region will be open. Okay. By the way, if you remember in the demo part at the beginning, I mentioned Terraform keeps output of all resources and its attributes, right? Outputs basically can be queried and retained. Output values are like the return values of a Terraform module. Like for demo purpose, I'll show you what output looks like real quick. It could be used for troubleshooting or whatever. So in the create instance, back to the main config file, create instance.tf. So scroll down below, I include a small block for outputs. So basically what this block does is just to return the public IP of the EC2 instance that we just created to the CLI terminal. You see here, basically here on our resource block for creating the instance, we are, for the value, we are showing AWS instance and my first AWS instance, and I'm gonna collect the public IP, and it's gonna return to my terminal. So we will see shortly in my terminal, and it's pretty much it. Let's jump back to the terminal to see if we get the timeout arrow yet. Okay, it's still repeating to trying to create the instance, and normally it will be timeout in 5 minutes. So let's give it a little bit more time, and we should see that timeout error soon. Here we go, the timeout error pop up. Okay, now let's jump to the AWS portal to add my IP to the security rule, so that connection will work. Here, just you can click EC2 or IAM. So I just click EC2, and inside of EC2, scroll down to the network and security session, and within network security, click security group. And here you can see this is the default security group. What you need to do is just to click this security group, and in the inbound rule section, click add an inbound rule and add a new rule for all traffic. And the source, instead of custom, click down, drop down menu and select my IP. So this is my the IP of my laptop. So save rules. So it's done. So now let's go back to the terminal and rerun Terraform apply to see if it works this time. Here, just issue Terraform apply. And issue yes to approve. Yeah, let's watch the log this time. So it's trying to create the key value pairs as we defined in the config file here, like resource key value pairs, right? And it's creating the security group, which is, you see, security group custom US West. This is exactly what I defined in the security group TF, right? The security group was custom US West, right? And let's go down. It's trying to create the instance and the setup connection. Okay, it's starting running that my shell script to install Nginx, etc. So okay, done. So here in the bottom, and you can see the public IP of the EC2 instance that was just created shown here. That's what that data block for in the bottom. This output block for. So it's showing IP address and it's showing in the CLI, right? So it's pretty much it. So let's go back to the AWS portal and see if my instance is there. So here, you see here, this instance was created, and let's go to security group, see what that that security block, security that Terraform that I created, what that security group created. So here you can see there is a custom security group created for US West, and if you click into it, and you can see it lists out all the available CIDR blocks inside that region, and it's automatically open port 443 for all those blocks once for all, right? Cool. So now, since the HTTPS 443 port was open, so we should be able to get access to Nginx from anywhere, basically. So let's try it out from my local. So let's jump back to my to the terminal to grab the public IP shown here. So if everything works as expected, and let's go back to the browser, just put in the IP, we should be able to see the Nginx running. Yeah, here we go. Nginx is up running. Cool. I think that's pretty much what I want to share for this session. And thanks for watching.
Alright, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.